So you guys had to do numbers 1 through 12? Yeah. It's your boy. Again. All right, guys. These should go quick. Let's go. So, number 1, let's jump around. Martina, what can I factor out of both these terms first? What number can I factor out of both these terms? 3. So I factor out 3. I have n squared minus 16. But n squared minus 16 is difference of 2 squares, because n is a square and 16 is a square. So that'll be 3, n plus 4, and minus 4. These need to, you guys, like, it might have taken you a bit, but honestly, by the time you're done with high school, before you're going to take college placement exams, these need to be coming quick. If you guys have any tips for how they made it be quick for you guys, then tell me. All right, absolutely. Number 2, what can we factor out of both, Stephanie? 3. 3x. Factor 3x out of both. We have x squared minus 25, difference of 2 squares, because x is a square and 25 is a square. 3x, x plus 5, x minus 5. Fantastic. Okay, Samuel. Can't factor anything out of both of those. However, 9m to the 4th and 16 are both what? They are. So, first of all, there are only 2 things. Samuel, there are only 2 items. It's a binomial. So this is either going to be non-factorable, could be, okay? It's not. It is factorable. Or it's difference of squares, difference of cubes, or sum of cubes. Now, that's a subtraction, so that means it's either difference of squares or difference of cubes. Is 9 a square or is 9 a cube? It's a square. Right? What squared makes 9? She's stealing it from you. Quit stealing his thunder. 3. You know that though, right, Samuel? All right.
No, I was just thinking about. Wait, you said what? You said cube.
I said this is difference of squares or difference of cubes.
Yeah, 3 squared is 9. I thought you said 3 cubed.
No. Okay. So these are both squares. So Samuel, what squared? So what in parentheses squared would make 9m to the 4th? 3m to the... So, guys, Sydney, ladies, I'm trying to help Samuel here, right? So 3m is squared, right? What would I have to put, what exponent would I have to put on the m that if I squared it, it would make 9m to the 4th? I have to put an exponent right there. What would I have to make it be, Samuel? Okay, so if I put a 4 right there and I squared that, would it be to the 4th here? I understand. I'm not trying to frustrate you. You're looking down to write. Do you want me to wait for you to write before I? Because I want to make sure I keep your attention. I'm not trying to get you angry or frustrated. Okay. So, Samuel, when I'm doing difference of squares, right, I need to be able to put this as squared. So 3m squared, this right here, would end up being 3m times 3m, right? But that wouldn't make 9m to the 4th. So yeah, if I put 3m squared right here, that would, so 3m squared means 3m squared times 3m squared, and that would be 9m to the 4th. So we have to watch out, and this is not something I hit heavily yesterday, that if I have an exponent above a 2 or a 3 right there, that I can break it down a little further. So, and then Samuel, what number squared makes 16? 4. So here's my difference of squares. So that's going to be 3m squared plus 4 times 3m squared minus 4. That's difference of squares turns into 1 plus and 1 minus. Tim, did you get that?
Yeah.
Okay.
Did Tim get his Krispy Kreme experience?
He did. It was the weirdest experience we've ever had at a Krispy Kreme in a life.
I'm so glad Mr. Bates a man of his word.
It's weird. It was weird. The lady that helped us was weird. Weird.
She gave us the entire.
Weird. It's a so.
I kind of.
Okay, I'd like to say 2 minutes, but we'll see. We'll see. I'll time myself
Let's
ish.
just finish this.
All right. I agree with you, Sydney.
No,
Alexa.
I'm trying to learn. Sorry.
Alexa, you're good. So 16. What is this? Difference of squares, difference of cubes. What is this?
Different squares.
It is difference of squares. 16r to the fourth would be what squared?
4r to the second. Sydney.
4r squared squared. Yep. Okay. 9 is what squared?
3.
3. You're not allowed to be square. Done, Sydney? Okay. So now we have difference of squares. We have something squared minus something squared. So that turns into 4r squared plus 3 times 4r squared minus 3. Sydney, you're up next. Sydney, what can I factor out of both those terms? 3n squared minus 12. This one, there's something I can factor out first, which is 3. Factor out 3. I have n to the 6th minus 4. N to the 6th minus 4 is difference of squares or difference of cubes? So 4 is something cubed? No. We got to look at both terms. Now, be careful. N to the 6th could be is a cube, but it's also a square, right? Because I can multiply by 2 and get 6, or I can multiply by 3 and get 6. So if you just look at n to the 6th, you might not know. So 4 gives us our clue. It is going to be difference of squares. So Sydney, what is n to the 6th as a square? What squared makes n to the 6th? What squared makes n to the 6th? What would have to be in here and then square it, and I get n to the 6th? Yeah.
So lost.
No, I know. Right? That makes n to the 6th? Okay.
Oh, yeah.
I know, and I didn't know how else I would say that, Sydney. That's why I had like bring my hands in and everything. So obviously this worksheet loved difference of squares.
Yeah.
Oh yeah?
Isn't it?
Yes, sir.
So 5 was totally.
Isn't it n3 or n3 squared plus 2?
No. Because of the fact that each of these items is squared, that lets me break it into that thing plus and that thing minus as well. If you look at the...
Oh,
Oh, you're good? Okay. Tim. X to the 6 minus 9. Difference of squares or difference of cubes?
Difference of cubes.
Oh, 9 is a square.
Squared.
All right. So this is the same question I basically asked Sydney. X to the 6th is what squared? Is what squared? It's something squared. What would it be? Like 9 is what squared?
Oh, 3.
9 is 3 squared. So x to the 6th is what squared?
1 and 6.
No. Like in other words, it would be x to the what squared would give me x to the 6th.
Oh, x5.
Nope. 5 squared. X to the 5th squared would be x to the 10th.
X to the 1st squared.
Third, yeah. X cubed squared. So now I've got something squared minus something squared, so that turns into x cubed plus 3 and x cubed minus 3. This one was like easier than number 5. I don't even know. I don't even know why. I don't know what order they make these problems in. I always come from that old school mentality that each problem is supposed to be a little harder, but they're not. They're all over the place. Any questions on 1 through 6 before we do 7 through 12? Aaron? 2?
Yeah, I don't get where did you get 25?
So when I take a 3x out of both of those items, 75x, if I take 3 out of it, there'd be 25 left over because this is dividing. 75 divided by 3, right? And if I take an x out of 75x, there'd be no x left on the 25. That's where I got 25 from. Josiah? Okay. Yeah. Yes? 5? So 5, I factored the 3 out of both. You're good there? Okay. End of the 6 and 4, they're either both cubes or they're both squares if they're something, right? 4 is a square. End of the 6 is an even, so it's also could be a square. Okay, as long as it's an even power, it could be a square. If it's a multiple of 3, it could be a cube. 6 happens to be both an even and a multiple of 3. So it could be one or the other. I look at 4. 4 is a square, not a cube, so I'm going to do difference of squares. Okay? So difference of squares means I need something squared minus something squared. End of the 6th is n cubed squared. 4 is 2 squared. If I have a difference of square, I was going to write this down a second ago. If I have a squared minus b squared, something squared minus something squared, that turns into a plus b times a minus b. All right, that's from the top of the note page, right? So whatever it is squared, it turns into the non-squared plus the non-squared minus the non-squared. So the non-squared n cubed plus the non-squared 2 times the non-squared n cubed minus the non-squared 2. Okay? That's what's going on each of these. So hopefully Aaron and Dylan are really tuning in. Alrighty. 7 to 12. Jaden, you're up. Jaden, first of all, what can I factor out of every single term there? And? 3b. I can factor 3b out of every term. So I'd have 3b. If I take 3b out of the first, what would I have? If I take 3b out of this, what would I have left? No, the 3's gone. B to the 6th. If I factor 3b out of 12b to the 4th, what would I have? 4b cubed. Mm-hmm. And if I take 3b out of 12b, what do I have left? 4. This is only one thing it could possibly be if it was something. I could use the Xbox method if I wanted to, but this is a what, do you think, from the notes? Mm-hmm. No. Sorry if I started saying too early. It is a perfect square trinomial. It is a perfect square trinomial because what number is in front of the b to the 6th? 1. What's this number? Okay. So what number squared makes 1? 1. Okay. What number squared makes 4? 2. So is this number 2 times 1 times 2?
Yeah.
Yes. That's how you check a perfect square trinomial. You check the square root of the number in front of the first term is 1. The square root of the last number is 2. 2 times 1 times 2, does that make?
Where'd you get the second 2?
So if you look at the formula, it has a 2 built into it. A perfect square trinomial, there's always a 2. It's 2 times the square root of the first times the square root of the last. So this is a perfect square trinomial. So this is something squared. Now, if not, let's you know what? Just for the heck of it, really quick. I mean, this is obviously not going to fit because we're going to do this. It'll be fine. Okay. All right. So what would go in my top? Close. 4b to the 6th. Right? Because the first time's the last. First time's the last. What goes in the bottom? 4b cubed. What would multiply to 4b to the 6th? Either 1 times, or sorry, b, I should say, b to the b cubed times, so split that in half, right? B cubed times 4b cubed. That would make b to 4b to the 6th, right? Yeah. B cubed times 4b cubed, that would make that. Okay. Or 2b cubed times 2b cubed. That would also make 4b to the 6th, right? Which one of those two would add to 4b cubed? The bottom one. The bottom one. Yes, Alexa. Yes. Yeah, they add. Yeah. Yeah. B to the 8th times b to the 7th is b to the 15th. Yeah. So those would add to 4b cubed. So 2b cubed, 2b cubed. Are you okay with that so far? All right. So now I put b to the 6th, 4, 2b cubed, 2b cubed, right? If I factor going up, what can I take out? B cubed. If I factor up, what can I take out? 2. If I factor that way, what can I take out? If I factor left, I can take out. But what do you notice about both those? They're the same, right? B cubed plus 2, B cubed plus 2. So coming back all the way back to it, this is a perfect square trinomial. This is a perfect square trinomial. So it's just going to be, well, the 3b is hanging out front. The square root of that, which will be b cubed, plus the square root of that, which is 2 squared. There's 2 of them. The x box will still work. The x box will still work, but if you don't remember perfect square trinomials, but it still works out, you know. But if you know perfect square trinomials, it'll end up being that. Johnny's turn. They're going to do the same thing to Johnny on this one. Yes?
When we were factoring it, like initially, why did the exponents go down?
Why'd they go down one?
Yeah.
Because I took out a b. I took out a b when I factored. So if I took a b out of b to the 7th, it would drop down to only 6 b's. Because each one can give up a b, since it's the same in every one. If, like on 8, I'm not going to be able to take a v out, because 18 doesn't have a v to give up. So I won't take a v out. Johnny, what can I factor out of every term here? 2. Yeah. Not a whole lot I could take out. So I get 25v to the 6th plus 30v cubed plus 9. So is the first number a square, Johnny? Is 25 a square?
Yeah.
Is 9 a square?
No.
Yeah, it is.
Oh, yeah.
Yeah. So what is the square root of 25?
5.
What's the square root of 9? Okay. Is 2 times 5 times 3 30?
Yes.
Yeah, it is. So this is a perfect square trinomial. Johnny's on the answer unless it... What's up?
Wouldn't it be 25b to the 3rd? Because if that was 30b4 to the 4th, the 3 times 5 times 2 is still 30. But it wouldn't be a perfect square.
That's what I said. I don't know about to the 4th power. I don't know where that came from, but everything else you said was accurate.
I know, but like if it was 30b to the
Oh, if it was 30v to the fourth, this would not be a perfect square trinomial. No. No, the exponent here has to be exactly half of the first one.
But the exponent stays the same?
Hmm?
The exponent stays the same? Even though you halved it?
What do you mean?
You divided them by 2.
Oh, yeah, I didn't take a v out, so all the exponents stayed the same. All right, Johnny. So trying to use this algorithm here that we used on number 7, instead of using the Xbox method, what would be, so I've got the 2 hanging out, what would be the first number? 5v cubed plus 3. There we go. That is correct. Tim. Thank you. All right, where am I at? I'm to Michael. Number 9. What is it? X cubed. Is that a cube or a square? It's a cube. Tends to happen in the name. 64. Is 64 a cube also? It is. So this is difference of cubes. So Michael, what is 64? Is what number cubed?
8.
8 cubed is 256. 4. 4 cubed. So this is x cubed minus 4 cubed. So I know my guys, a lot of times, and on my notes, I was able to write it out nice and big and obvious. On these, we only have one little line. The key to using each of these formulas is identifying what A is and what B is. So in this case, A is x, B is 4. And now I'm going to apply the difference of cubes formula, which says A. What's A? Michael? I said it a second ago. That's B. So A is x. So my difference of cubes formula says A, which is, once again, x, minus B, which is 4, times A squared. What would be A squared? X squared, plus A times B. What's A times B? A is x, B is 4, so what would A times B be? 4x. A is x, B is 4, so A times B is 4x. Plus B squared, what would be B squared? 16. And we're done. A little brutal. Come on, Michael. Yeah, stay with me. Josiah.
Wouldn't it be the difference of 2 cubes?
Yeah?
Which would make it negative 4x.
Yeah, x squared minus.
I disagree.
Never mind. No, I'm looking at sign.
Remember SOAP.
Yeah.
It's the same sign, then the opposite sign, and the last one's always positive.
So.
Yes, Johnny.
Wouldn't 16 be squared?
No, 16 is 4. It's 4 squared. Because it's A squared plus A times B plus B squared, and our B was 4.
You got the dirty, bro.
Dylan, you think you could try number 10? I think you could. So look at the top. Look at the top of the page, right? The little formulas. Michael, point them out to him if he doesn't see them. Is this a cube or a square? It's a cube. Is 125 something cubed?
Yes.
Yeah, what? Probably. 25 cubed is 3,125 or something. No, it's actually even more than that. It's 15,625. So 5, yeah. We're not that big of a number, 5 cubed. So this is x cubed minus 5 cubed. So what's my A, Dylan? What's my B? 5. So now using difference of cubes formula on that page by your left elbow at the top of the page, it would be A minus B. So I'd write down what? X minus 5 times A squared. What would be A squared? X squared plus AB 5x plus B squared. Yeah. That's it. Yep. That's factored. Yvonne. Yeah. Yeah. Come on. You got this. You do. I believe in you. All right. So this is, I believe this was actually an example I showed you after school yesterday, wasn't it?
I asked the question.
So
It was close.
this wasn't the exact number I gave you after school yesterday in your dad's room? No? So there's a problem with this one, Yvonne. You can go 2 ways. Yeah, Yvonne gets the complicated one. This is how much I believe in her.
Yeah, no, she got this.
Okay. So, no panic attack. So here's the problem, Yvonne. X to the 6th, is that a square or a cube? Sure. X to the 6th is 2 cubed, right? If I take x squared and I cube it, x squared times x squared times x squared, that would make x to the 6th, because there would be a 2, a 2, and a 2. That makes 6 of them, right? But it's also a square. Because if I take x cubed and square it, I'd get x cubed times x cubed, which makes a 3 and a 3, which also makes x to the 6th. Now, there's a problem here, Yvonne. 64. Is that a square or a cube? Square. What squared makes 64? 4 squared makes 16.
Oh, I know this.
What number? 8. 8 squared makes 64. But unfortunately, 64 is also a cube. So this whole thing, you can go one of 2 directions with number 11. One of them is better than the other. You can count this as a difference of squares or as a difference of cubes. If this were a quiz, either way you go, as long as you go to the end, you'll get 100% credit. But one of them is better than the other because one of them breaks it down just a little further.
Would it be squared?
It is going to be difference of squares. So we're going to go with Yvonne's first answer and go with difference of squares. So there's going to be lots of room for this one. So I don't know how you guys necessarily want to write it, but it's going to take up 2 lines. It's going to take up 2 full lines, okay? So Yvonne, we said a second ago that you could turn that into x cubed squared, right? And you said 64 is what number squared? 8 squared. Right? So if this is difference of squares, Yvonne, my A is what? So look, going off the formulas from the top of the note page. Okay, you there? Cool. This is difference of squares. What is my A value? Because difference of squares at the top says A squared minus B squared. So what is the A is whatever the first thing squared is. What's my first thing squared here? It's that whole thing. What is taking the place of a? That. X cubed. The entire thing. X cubed is my full value of a. What is my b then? Just the 8. B doesn't have. What is b? B is just the 8. Okay? So a is x cubed, b is 8. A is x cubed, b is 8. So then if I were to break it down using that formula, it says difference of squares, a squared minus b squared equals what? A plus b. So let's stop for a second. A plus b. What's my a? X cubed. A plus b. What's my b? 8 times a. What's my a? X cubed. Minus b. What's my b? 8. So that's how difference of squares works. I have something squared minus something squared, something plus that, something minus. Now, there's an issue. Because what do I have in front? X cubed plus 8 is actually something. Yvonne, what is it? X cubed plus 8 is actually another thing that I can factor. What is it? If you're looking at the chart at the top of the notes. There's only one thing that's got a plus between it and only 2 items. What is it? Yeah. Huh?
You're saying it's like a whole other.
So there's only one thing here that has, so looking before the equal signs,
Okay.
right? Only one thing has 2 objects and a plus between it. What is it? You see it right here?
Yeah.
2 objects and a plus between it. Sum of 2 cubes. Because 8 is a cube. 8 is a cubed. But this is what? Now this one, x cubed minus 8, is, so it's a difference of 2 cubes. So this is technically x cubed plus 2 cubed times x cubed minus 2 cubed, which now can be factored. Sum of 2 cubes, x plus 2, x squared minus 2x, don't know why I put a 4. Difference of 2 cubes. This whole thing breaks into a double, this thing like triple factors out. It's like when you first learn how to factor, like a number, and your teacher's like, what does 6 factor into? And you're like, 2 times 3, and you feel so proud of yourself. And they're like, what's 9 factor? And they're like, 3 times 3. And what's 4 factor? 2 times 2, and you're just feeling so amazing. And then the teacher's like, what does 12 factor into? And you guys are like, 6 times 2, and you think you're done. And they're like, 6 factors further. And you're like, oh, you got me.
Oh, shucks.
Yeah. That's when you pull your GRU like you did yesterday, and you're like, I see what you did there.
Funnier make stuff when you have accents like Mr. Bates.
So.
That'd be such a funnier person, bro.
All right, just for time purposes, because I've got to finish this and give you guys your homework tonight. There's no ifs, ands, or buts about it. 12 works just like 11. It factors in a difference of squares and then difference of cubes again. So because this is going to be x cubed, this is difference of squares, x cubed plus 1, x cubed minus 1. But those are both sum of cubes and difference of cubes. So that's x plus 1 times x squared minus x plus 1, and x minus 1 times x squared plus x plus 1. So just for time purposes, running through it, Aaron, I know you were looking forward to doing that one all on your own, but I'm stealing your thunder. Okay, the last section, guys. Factor by grouping. Now, I wrote down that when you have an even amount of terms, so 2 terms, 4 terms, 6 terms, 8 terms, right? 2 terms, it's a little redundant. You don't really need to worry about 2 terms. Okay, if you have 4 terms, 6 terms, 8 terms, so on and so forth, you can try to factor by grouping. You should try to factor by grouping. For the most part, you're only going to get 4 terms at a time when we do factor by grouping. Okay? It works quick and easy. I think in 13 minutes, I should be able to get the lesson out to you. We ready? Okay. So we have x cubed minus x squared plus x minus 1. Okay. So what we do is we take them 2 at a time. Sometimes you need to rearrange them. For now, we're just going to worry about take the first 2 as a group, take the second 2 as a group. If I take the first 2 as a group, x cubed minus x squared, what could I factor out of both of those? X squared. Remember, you can only give up as much as the smallest one's got. I can take an x squared out of both of those. If I take x squared out of x cubed, what's left over? X. If I take x squared out of x squared, what do I have left? 1. What could I factor out of x and a negative 1? 1, because there's nothing the same. Between x and negative 1, there's nothing the same between the two. So I could take 1 out of it. If I divide x by 1, what do I still have? X. If I take 1 out of 1, what do I have left? 1. We're not subtracting, remember, we're adding. We're dividing. I said we're not subtracting or adding, we're dividing. When I factor. So when I divide by 1, it's not doing anything. Everybody okay? I took an x squared out of the first 2 terms. Okay? I divided a 1 out of the second 2 terms.
Yes.
What do you notice about my 2 parentheses?
They're the same.
They're the same. I appreciate the enthusiasm.
I thought it was getting a little thin.
Okay. So, here's the big concept you need to wrap your minds around. Big concept you need to wrap your minds around. Really fast, go back a page. Everybody okay? Like when I factored 2 out of this, right? I put a 2 out in front, and then I divided each item by 2. We're all good? Yeah. When you factor by grouping, you're pretending now that this is one item, and that this is one item. So what could I factor out of each item? Leticia is right. X minus 1 is what I could factor out of each item. They both could give out an x minus 1. So out in front of all of it, I factor out an x minus 1. If I factor x minus 1 out of this first object, what's left over? X squared. If I factor x minus 1 out of this object, what's left? And it's factored. Aaron. Huh? So yeah, I'll repeat it in a second. People are writing. When people are done writing, I'll repeat it. Getting your samurai on there, Dylan? All right, Aaron. Are you okay that I took an x squared out of the first 2 and I got that? And are you okay that I divided 1 out of the second 2 and got that? Okay. So if I look at this as one object and this is the second object, I look and I say, what can both objects give up? They can both give up an x minus 1 because they both have an x minus 1. Okay? So if I take an x minus 1 out of both of them, I put it out front. If I take x minus 1 out of this, what's left? X squared. If I take x minus 1 out of this, what's left? Plus 1, and I'm done. Okay? We're going to do the exact same thing, with just like a little bit of a sign change, a little bit of a difference. And next example. So Aaron, what could both my first 2 terms give up?
It's x cubed.
Huh?
It's x cubed, not x squared.
The second one example? No. Oh. Right there, you mean? Got you. Okay. Yeah, these both could give up to x cubed, right? So Aaron, if I take an x cubed out of the first thing, what do I get? X. If I take x cubed out of this, what do I get? 1. Aaron, what's common between these 2 objects? Yeah. Nothing. So whenever there's nothing in common, the only thing I could factor out is 1. So I factor out 1, which means I'm not changing anything. Like I said, these examples are almost identical. So now what could both items give up? So Sydney, since you were so exuberant in your solution, am I done? Not Sydney, I'm sorry, Gabrielle. I don't know why I called you Sydney, Gabrielle. Gabrielle?
You're not done because you can still get the
Sum of 2 cubes is sitting right here. Sum of 2 cubes is sitting right here. X cubed plus 1 is the sum of 2 cubes. And now I'm done.
So what? Finish the first one. Finish the first one.
What do you mean? Alexa? I don't know what you mean by the first one.
Because the first one was x squared plus 1. So we couldn't do anything for that one?
Right, there is no sum of 2 squares.
Okay. Just a difference.
Just difference. Yes, Johnny? Yeah, I could go further. Whenever I notice I can go further, I go further. Aaron? So Aaron at the way up here. Yeah, sum of 2 cubes. I have a number cubed plus a number cubed. So I have x cubed, which is a, right? A is my x. Yeah, and b would be 1, right? So then I write it as x plus 1 times x squared minus 1 times x plus 1 squared. Mm-hmm. All right. Last one. Amanda, I think you're up. Only because Gabrielle made me jump over to that side. Yeah. I'm wondering whether or not I made a typo.
Oh, wait, Mr. Bates.
This looks pretty tight.
Hmm.
X squared, 3x squared, and 3x, and then group x cubed and 2.
That still won't give me what I want.
Well, you can factor the, factor out 3x.
But I want to get the same. So so Josiah, like if I grouped these two, right? Just jumping ahead, right? But then I'd still have And I haven't done anything with those, and I'm not going to be able to get an x plus 1 out of them.
Wait, what?
So there is a typo.
Yeah, so more than likely I've got to change something really fast. Um,
I'll work with it still.
just for time purposes, unfortunately, it's going to be as easy as it has been. I just don't want to mess with it that much. Go ahead and make that change. Go ahead and make that change. Turn it into that. So, Amanda, what can I factor out of the first two terms? X squared. And what would I have left over? Uh-huh. What can I factor out of the second two terms? 1. There's nothing in common. Then I have x plus 3. Malika? Huh? Okay. Yes. I asked you to change it to that. All right, so Malika, what can I factor out of both those? So if I look at it as this is one thing and this is another one thing. The x plus 3. What would be left in here if I take out the x plus 3? No. The only thing that would be left was, if I took x plus 3 out of this first thing, the only thing left would be x squared. And if I take x plus 3 out of this, the only thing left is the 1. And that'd be done. Do I know how? What? Uh-huh. No, because factoring is all division. There's no subtraction involved. So I thought I'd have more time. It's a good thing Sydney stopped my story from occurring. Good job, Sydney.
Now can you tell us a story?
No, because now I've got to pass this out, and you guys just have seconds left. But since I thought we'd have more time, you guys got a print out for your homework sheet, so you don't have to write it yourself.
Gracias. Thank you.
Just put no name, and you can put them in this folder right here on my wall. Josiah, you don't got to waste your own printer ink.
This. Oh, really?
Oh, that.
Do I give him
That's he does. I talked to him about that.
I'll give him a 1?
Yeah. Tim? Oh, I gave you one already?